This session will be recorded so that you may come back to it later if you need, and so others who may have missed out on today's events will be able to come and watch it. Thank you. So now, at this time, please mute your mics for the best sound experience, otherwise the feedback could interfere with information we will be sharing. We'll be sending the 1324 room link on the chat so that you may connect to your session if you're here for Math 1324. We'll also be sending individual messages to everyone to gather your student ID numbers to sign you in. Without further ado, I'll pass it on to our presenter so that we may begin.
Hello, everyone, and welcome again to Friday's Happy Math Hour. For those of you who are here for the Math 1324, go ahead and click on the link that's on the chat. I believe it's on there already. If you're here for the Math 1314, stay here. So we'll go ahead and get started. So today we're going to cover section 2.5, which is finding zeros of polynomial functions. All right, so we kind of explained this our last session for our math happy hour, where when we're finding the zeros, okay, what we want to find is the x-intercepts, right, where the graph is crossing the x-axis. So we like to see our functions factored out. When they're factored out, we're able to see where the values for x give us 0, right? That will cross our x-axis. So it might be a little bit more complicated if it's not factored, right? So this is what we're going to cover today. So let's start first with what's called the fundamental theorem of algebra, okay? And this says that for a function who's a polynomial of degree n, where n is greater than 0, it has at least one 0 in the complex system. So let's go over this. So determine the number of zeros of the polynomial function. So as we've studied before, if we look at our first example here, this function, the degree of this function is of degree 3. So this function here would have at most 3 zeros, okay? And if we are looking at this second function here, even though it's not in standard form or descending order, we look at the highest exponent. And if we look at our highest exponent here, our highest exponent is 6 here. So our function for this one is a degree 6. So this function should have at most, or at least, 6 zeros. Okay, so this is a quick way to find out how many possible zeros you're going to have. Just look at the degree. Okay. All right. So now let's find the zeros for each of these polynomials. So the first one, it's pretty easy. It's we have a linear function. So if we wanted to find the zeros, okay, we set the function equal to 0. So and then we solve for x, and we see that at x equals 2, again, this linear function, this line, is going to cross the x-axis here at 2, 0. Yes? So when y was 0, x is 2. What about b? So here we have a quadratic. Again, you could have used a quadratic formula or factored this to solve the zeros, but you'll see that this has it does have 2 zeros, right? When the graph touches the x-axis and then turns around, this is called a double multiplicity, right? So this at 3, 0, we consider that it's a double 0 at 3. Okay. So again, if you can see it here, if I factor this out, I have x is equal to 3 twice, right? So this is what's telling me that the graph is touching and then turning around. It doesn't cross our x-axis. Okay. And then if we look at C here, C, when we factored this out, we have some imaginary numbers, right? So these complex numbers. So this was a cubic function, right? But we do have some complex zeros. We have the 2i and the minus 2i. Okay. All right. So let's go ahead and find the zeros for the polynomial given that x is equal to 4. is a zero. So on this particular problem, they're already giving us one of the zeros, which is nice for us. So what we want to do is we want to use synthetic division to find the rest of the zeros. So again, we covered synthetic division before. So what I need to do is I'm going to divide by one of the 0, 4, so I can reduce this polynomial. Okay. So first of all, if I'm going to use synthetic division, I got to make sure that it's in the right order, in descending order, and I have a placement value for each of the terms. So if you see here on my polynomial here, I'm missing the x squared term. So I'm going to use a 0 to represent the placement of that x squared that I don't have. So again, I'm using only the coefficients because I'm using synthetic division. So it's 1, 0, negative 13, and negative 12. So let's go ahead and do synthetic division. Synthetic division, I bring down my 1, and then I multiply 4 times 1 is 4, 0 plus 4 is 4, 4 times 4 is 16, negative 13 plus 16 is 3, 4 times 3 is 12, and negative 12 plus 12 is 0. So I knew that my remainder was going to be 0 because they told me that 4 was a 0, okay? Or x equals 4 is a 0. But I used it in order for me to reduce this polynomial. I started with a degree 3 polynomial, but when I did synthetic division, I'm going to end up with a quadratic. So if I rewrite this, okay, I can see that I have x squared minus 4x plus 3. And now in this format, again, I can use many of my arsenals to solve for the x-intercepts. But again, our best way is, or my favorite way is factoring this guy out. So then we have x minus 3 times x minus 1. And if you don't see it, you solve for x, right? You said in order for this to equal 0, either x minus 3 is 0 or x minus 1 is 0. So again, I set them equal to 0, and I see that x is equal to 3 and x is equal to 1. And hence, I found all of my 3 zeros, right? This is a degree 3. I should have 3 zeros. So my zeros are 4, 3, and 1. Okay. Now, when you're answering your homework, don't forget to write the 4 that they give you. Right? When they say list the zeros, okay, don't forget to write the 4 that was in the beginning. All right, so let's look at this one. Find the zeros of the polynomial function. X cubed plus x squared minus 9x minus 9. So what is different from this example from the previous one? Well, they're not giving me a 0, okay? So then that's okay. What I can do is I can apply my rational um, 0 test that will let me find the possible zeros. Again, it's a test, okay? So a test can either be positive or negative, right? When we were in COVID, we always wanted to have a test negative. We never wanted to be positive, right? But anyway, no side joke. And this is a test. So this, when we apply this the rational 0 test, it could possibly give us all of the zeros, one of the zeros, or none of the zeros. It's just a test. And it's also, it helps us not to try just randoms numbers at random. We want to try to limit our possibilities of finding the zeros. So that's where this comes from. To find a possible rational 0 test, the way you do this is you're going to get the factors of the constant term. Again, the constant term is the one without a variable. It's the last one here in green. And we get the factors of the leading coefficient. And the leading coefficient is the one that has the degree, yes? Now, um, we are not going to worry about the sign because we are going to take care of both positive and negative. So let's do an example just to help you see what this means, okay? But before that, let's talk about what are factors, okay? So if I look at 8, the factors of 8 would be 1, 2, 4, and 8, right? So these are all numbers that when I multiply them together, I can get an 8, right? And then 24, what are the factors of 24? Well, that would be 1, 2, 3, 4, 6, 8, 12, and 24, right? These are all factors of 24, right? And these are products on how I get 24 and 8. So let's go back to our problem that they told us to find the zeros without them giving me one of the zeros. So I'm going to use a rational 0 test to find the possible zeros, okay? So on the first one, what is the constant term? So in my case, the constant term here is going to be the -9, the one without the variable. But again, I'm not gonna be worried about the negative. I just want the value, which is 9. And what is the leading coefficient factor? So well, here there's a 1, right? The degree is 3, so the leading coefficient here is 1. So what I'm gonna do are these. So the factors of the constant term are 9, so it's 1, 3, and 9. For the leading coefficient, that's easy. It's just 1, which is only 1, right? But again, I said that don't worry about the sign, because what we're going to do is we're going to look at the positive and negative of each of those factors. So I'm going to look at plus or minus 1, plus or minus 3, plus or minus 9. And I'm going to divide it over the factors of the leading coefficient, which was just 1, the plus or minus 1. Now, um, when you do the division, you get these 6 values. Now I do apologize. Word has, this symbol that I can do plus or minus, but when you're answering on your homework on WebAssign doesn't have this symbol. So you actually have to write +1, comma, -1, comma, -3, comma, +3, comma, -9, comma, +9. Okay. You'll have to do the list each individually. Okay. All right. So now that I have my possible zeros, let me go ahead and use synthetic division to see if I can find one of them. And once I find one of them, you'll see that um, we can use our quadratic or factors to solve for the rest. Okay, so again, I'm going to start with the 1. Again, I have my polynomial that's a degree 3, and I have a placement for all. I have a 3, 2, 1, and a constant. So let me grab the coefficients. I have 1, 1, -9, and 9. So I'm going to go ahead and apply synthetic division. Um, 1 times 1, I bring down my 1. 1 times 1 is 1. 1 plus 1 is 2. 1 times 2 is 2. -9 plus 2 is -7. 1 times a -7 is a -7. And -9 minus 7 is a -16. So what this is telling me that at x equals 1 is not a 0. So for me to have a 0 again before, we want a remainder of 0 here. If we have a remainder of 0, that means it's a factored value, right? Okay, so this is not a 0, so this makes us sad. Let's go ahead and try another number. Let's try a -1 again. So I'm going to go through the process again. And when I do this, okay, I see that, yay, now we're happy, right? We actually found a 0. This is telling us that x equals -1, we have a 0. And now to get the remaining zeros, because again, what's my polynomial? My polynomial is a degree 3. So I should have at most 3 zeros. So I found 1, -1. Let's find the rest. I should have 2 more. Okay. So my quotient, if I convert it back to an equation, I have, again, I reduced the degree. So I started with a cube. Now I'm left with an x squared. I have no x term, -9. All right. Oh, this one's easy to solve for our x, because what we can do is we can use our square root property. So we solve for x by adding 9 on both sides, take the square root of both sides, and the square root of 9 is plus or minus 3. So we found all of our zeros. Our zeros are x equals -1, x equals -3, x equals 3. Now, if they asked us to find the factors of the polynomial, okay, we just move the 1 to the other side again. Add 1 on both sides, add 3 on both sides, and subtract 3 on both sides. So the factors of the zeros can be written as x plus 1 times x plus 3 times x minus 3. Okay? And you will have some homework problems that will ask you, instead of the zeros, they'll ask you for the factors. Okay? All right, so let's look at this problem. Find the rational zeros of the polynomial. Enter your answers as a comma-separated list. If the answer does not exist, you enter does not exist. All right, so again, they gave me a polynomial, and I don't know any of the zeros. So the first thing that I'm going to do to find the possible zeros, so I'm not just choosing numbers at random, is to use my rational zero test to find the possible zeros. So again, here my value for my constant is 1. The value for my leading coefficient is 2. So here we have the numerator is going to be plus or minus 1. For the denominator, for our leading coefficient terms, It's going to be plus or minus 1 and plus or minus 2. So when we do the divisions, we have this, plus or minus 1 and plus or minus 1/2. Okay, so then let's go ahead and start. Again, best bet always, maybe sometimes, I want to say 8 times out of 10, maybe even 9 times out of 10, depending on your homework. The first or second or even the third is always one of the solutions from your possible zero test. Okay, so let's go ahead and use 1. Oh, and then again, before we gotta make sure, okay, I have it here, but you see I'm missing the x term, right? I have a 3, 2, I'm missing the x term, I have the constant, so my x term is gonna be 0x here, okay? So we have 2, 3, 0, -1. Let's go ahead and do our synthetic division, and we see that 1 is not a 0 because our remainder here, we had a remainder of 4. It's not 0, so it's not a factor. All right, let's try -1. So we try -1. Yay, now we have a 0. So again, we found a 0. X equals -1 is a 0. Let's find the remaining 2 because we should have 2. This is a degree 3 polynomial. We should have 3 zeros. So let's convert our quotient into an equation or function. So we have our quotient is 2x squared plus x minus 1. Again, we can factor or use our quadratic equation. I think let's factor this guy out. So we have 2x minus 1 times x plus 1. Again, if you don't see it, the only way that this product can equal 0 is if either 2x minus 1 is equal to 0 or x plus 1 is equal to 0. So I'll set those equal to 0. And I'll see that here for my first one, x is equal to 1/2. And for my second one, x is equal to a -1. Yes, so those are my 3 zeros, right? I have a -1 and a -1 and a 1/2. So what does that mean? I have 2 answers for the -1, right? So that means that my graph will touch at that point. It's not going to cross the axis, it's just going to touch. So again, -1 has a multiplicity of 2. Okay? So keep on reviewing the multiplicity. All right, let's look at this one. We have the function ct is equal to t squared minus t to the 6th power. Okay. All right. So here, my constants term, I don't have a constant term, is 0, but my leading coefficient, the value is -1. And again, what I'm looking at is the leading coefficient. The leading coefficient is the one with a degree. Since the degree here is 6, it's the highest exponent, my value here is that 1 again. So we have 0 divided by plus or minus 1. So our possible zeros are 0, right? And we could have done that without our 0 test. We know that if we plug in 0 here, 0 squared minus 0 to the 6 is going to be 0, right? But let's go ahead and use synthetic division with one of the zeros that we have. Again, I have degree 6, so my first one is -1. I don't have a 5. I don't have a 4. I don't have a 3, so those are all zeros. I did have the square, so that's 1, but I don't have a single t, and then my constant is 0. Okay? So let's go ahead and do our synthetic division. And when we do this, we see that we have a quotient. Now negative t to the 5th plus t. But again, I wouldn't know how to factor this, so let's do it again. Let's go ahead and reduce our polynomial by doing synthetic division again. So if I do synthetic division again, I reduce the degree. Now I'm to the t to the 4th. And actually, I could probably stop here, but let me see. Do I stop here? Because I can probably use different. No, no. Let me continue. Let me continue. So uh, this is what I was thinking of doing and went ahead and did it. So this is, we're going to factor this guy out to this, right? Negative t squared minus 1, t squared minus 1. So if we solve for this, we see that t is equal to, for the first one, t is equal to plus or minus I, right? So we know that the square root of -1 is going to give us that is this imaginary value. And then for the other one, we have t is equal to plus or minus 1, right? So this will give us our list of zeros, right? We know that at the 0 we have, because we had a double multiplicity, it touches the graph, okay? And then we have the -1 and the 1. for our zeros, and then we have two roots that are not on our plane because they're imaginary. Okay. All right. So again, these are our zeros: 0, 0, 1, -1, 1, and the -1. Okay. All right. Let's look at this next example. Um, Find the zeros for this polynomial. Again, what's my degree of this polynomial? We have a degree 4, right? And do I have a placement value for all? We have 4, 3, 2, 1 constant. So we have all of them. So what I want to do is I want to find the possible zeros in order for me to find one. Um, so yes, it is a nice polynomial, right, Ms. Chuka? All right, so let's find the possible zeros. So my constant in this case is 24. So the factors are 24 are 1, 2, 3, 4, 6, 8, 12, and 24. And then our leading coefficient is 9. So the factors of 9 are the 1, 3, 9. So on this one, we're going to have quite a few possible zeros, right? So if we do the division for all of these, we have all these. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So we have 32 zeros, right? But how many should we only have? We should have at least at most 4. Again, this was a test. This was telling us the possible zeros. So again, let's just gonna start from the beginning. The first one that I'm going to try always is 1. Is 1 a 0 for this? So we see that we have a remainder of 30, so 1 is not a 0. Um, let's go ahead and do -2. Okay, so I'm going to skip the -1. I'm just going to go to the -2. And if you see here, when I do the -2, yay, um, -2 is one of my zeros for the polynomial. So now what do I have? What I have left is a quotient. But again, this is difficult to factor or even solve. So what can I do? So one of the things that we can do is, again, repeat our process. Go ahead and use my long list of possible zeros that I have now from my constant, which is 12. My leading coefficient was just 9. And it gives me this list again. Again, I'm going to choose, since I had already chosen um, 1 and -2, let me choose 3. So if I choose 3, oh, again, we have another 0 at x equals 3 is another 0. And we are so happy because um, we are now left with a quadratic. We have 9x squared minus 4. And on this one, again, I'm going to use my square root to solve for the x. So I'm going to add 4 on both sides, divide by 9 on both sides, take the square root of both sides. So the square root of 4 over 9 is plus or minus 2/3. Okay, so I found my zeros. So my zeros altogether we have is that the first one that I found, that x equals -2. And then when I did the synthetic division again, I got that x equals 3. And then when I used just my square root feature, I have the plus 2/3 and the minus 2/3. So these are my 4 zeros, right? At degree 4, I should have 4 zeros, -2, 3, 2/3, and -2/3. The factors of these would be x plus 2, x minus 3, x minus 2/3, and x plus 2/3. Yes? All right. So again, let's do this next one. So we have x cubed plus x squared minus 9x minus 9. So we had previously done this one, but let's go ahead and answer how you might see it on the homework. So on the homework, it's going to ask us list all the possible zeros of f, list all the real zeros, and then possibly sketch the graph. Now again, in your homework, it's going to be a multiple choice, but we can sketch it. So again, so when we did our zeros, we list the possible zeros, okay? And when it says possible, okay, it doesn't say how many zeros should this function have. What are the possible? What they're asking us is to use the rational zero test to find the possible zeros. So the possible zeros were plus or minus 1, plus or minus 3, plus or minus 9. Now it says to list all the real zeros. So these were our answers. Our real zeros were x equals -1, x equals -3, x equals 3. Okay, as a list, I would write them like this: -1, comma, negative. Excuse me, -3, comma, -1, comma, and 3. And then to sketch, again, we know that for sketching purposes, we have a lot of stuff that we've learned already. We can use our end behavior to look at how the graph behaves. We know our zeros. We know if, since it's the multiplicity will tell us if it's crossing the graph or just touching the x-axis. And we can also get our y-intercept. So with all this information, again, we can graph it. So just to review, this is our, our information for our end behavior. If we have an even function that our leading coefficient is positive, the graph will rise on the right and rise on the left. If we have an even function that our leading coefficient is negative, then that means that our end behavior is going to fall on the right and fall on the left. Okay? If we have an odd polynomial or odd function, if the leading coefficient is positive, it's going to rise on the right, fall on the left. If we have an odd function that our leading coefficient is negative, it's going to rise on the left, fall on the right. So which behavior do we have for our function? So in our function, hopefully we see that since our degree is 3, 3 is an odd number, so this is an odd function. And since our leading coefficient is a positive 1, the answer for this one is going to be this one, right? It's going to rise on the right and fall on the left. Okay, so now that I know that it will fall on the right and of my end behavior, okay, now what I can do is use my zeros to plot them. Okay, so here are my zeros, -3, -1, and 3. And we know that they cross the axis because I don't have any double, right? I don't have any double multiplicity, okay? My y-intercept, if you don't see it, we set x equal to 0, and we're going to get that -9, right? 0 cubed plus 0 squared minus 9 times 0. All that is 0. 0 minus 9 is that -9. Now, again, we can also pick additional points to plot. And, oops, my graph is not coming. Let's see if it's at the end. Well, so again, I skim forward, but let me see. Let me want to draw them. Let's write it since it's not showing up. Let's draw them. Okay. But I need the sketch. So let me draw it here. So let me pull out my pen. Okay, so this is my x-axis. This is my y-axis. Okay. So here, okay, I know that it's gonna cross the x-axis at -3. 1, 2, 3. So this is -3. So right here, let me use a different color so I can point out. Let me see if I can. There we go. Okay. So here at -3, I have a 0. It's crossing the x-axis. Here at -1, it's crossing the x-axis. And 1, 2, 3, let's say that this is 3 here. It's crossing my x-axis. Okay. I know because of my end behavior, since it's an odd function and my leading coefficient was positive, it's rising to the right and it's falling to the left. Okay. Now, this is where we talk about the additional points. Okay, well, and then we also have our x-intercept. We know that, our y-intercept. I know that it's crossing the y-axis here. I believe this is 0, -9. So I know these are the points that I have. Okay, so I mean I can be very liberal and I can join this like this. Okay, but where I don't know how far it goes over here, this is where additional points. So if I wanted to be accurate, that additional point that I would pick -2. What value when x is equal to -2 is the y value here. So if I were to do this, okay, I would do this. F, my additional point would come from valuing at -2. So then we have -2. So then we have negative uh, -2 cubed plus -2 squared minus 9 times -2 minus 9. Okay, so here the -2 cubed, this would give me a -8. -2 squared would be a +4. And -9 times a -2 would be a +18. And then the -9. Yes? So 18 minus 9 is 9, plus 4 is 13, minus 8 is 5. So at 5, when x is equal to -2, let's say that this value here is 5. I have this point here. And voila, I can just now connect my graph. And again, I can show you this pretty graph over here, right? At 5 here is where this point was here at -2. And again, we're able to sketch it. And the whole point is just to be able to sketch it because, again, the computer is going to do a much nicer job as far as graphing it or giving you an idea of what the answer is. Okay? All right. So let's look at this one that has an imaginary number, a complex number, right? So it says find the polynomial function with the real coefficients that have the given zeros. Okay, so what we want to do is our goal is to get all of the factors, and when we multiply all of our factors, we are going to get our polynomial. Okay, so this is what I like to use is what's called the linear factorization theorem. Okay, so on this particular one, they say that I have two zeros. At x equals 3 is a 0, and at x equals -4i is a 0. Okay, so um, therefore, we know that this is going to give us a degree 3 because this is an imaginary number. We know that imaginary numbers, we always have two. It's either the plus or the minus. So even though they're not telling us that there's a double here, we know that there is the +4i here. So when we multiply all these, this is going to give us our degree. Okay, so what we want to do is we want to list our zeros as factors, as we had covered before. So the factors of x equals 3 are, sorry, the factor of x equals 3 is x minus 3. The factor of x equals -4i is x plus 4i. The factor of x equals 4i is x minus 4i. Okay? So what I can do is I can multiply all these. And again, I'm not telling you, but what I'm using here is what's called the linear factorization theorem that says that if I multiply all of the factors of a given function, I will get back the polynomial. Okay, but for that theorem, um, there's an a sub n, our leading coefficient. But don't worry, I'll show you how to get the value of the leading coefficient. With this information, I can get the factors, which are here. Okay, so that's what I'll do first. I'm going to multiply all those factors together. And again, I like to start with the outer out first to do my FOIL. So the x times the first term, which is the x times the -4i, and then the 4i times ex, and then the 4i times the -4i. When I do that, Okay, I'm going to get this x squared minus 4ix plus 4ix minus 16i squared. Okay, combine my like terms. Minus 4ix plus 4ix is 0. But we know that I squared is the same thing as -1. So I can replace that here. Okay, and this is going to give me now a sub n times x minus 3 times x squared plus 16. So I'm going to do it again. I'm going to do FOIL. I'm going to multiply the x times the x squared, the x times the 16, the minus 3 times the x squared, and the minus 3 times the 16. When I do that, I get this, x cubed plus 16x minus 3x squared minus 48. I don't have any like terms to combine, so I can leave it like that. Okay. Now, I just rearranged it because I like it in descending order. So we left with this concept like, well, I don't know what my a sub n is. So to do that, what we can do is here, why am I using 1 here? Um, let me do this. On this particular one, 3. Here, let me show you with this one. Let me show you with this one how to get my a sub n. Okay. So let's. Yes, ma'am. Go ahead.
I was just gonna say, there's some problems that will not give you enough information to find the a sub n. So when that happens, then you can use 1 or any number on your WebAssign and it will count it correct. But the next problem, it will give you that information.
Right, and I saw that. Thank you, Ms. Chuka. So that's why I just went to the next one, because on this one, thank you for pointing it out. Since they didn't give me enough information, as Ms. Chuka said, if I put the 1, they're going to count it right. Okay. But with this problem, I can show you they gave me enough information for me to be able to solve for what that a sub n is. Okay. So let's go ahead and do this one. Let me show you fully how to find our polynomial with this given information, and also finding that a sub n, my leading coefficient. So the first thing that I need to notice, or they're asking me, is they want me to come up with a polynomial with a degree 4, and they give me these zeros, minus 4, 1, and I. Oh, I know that I, even though they just gave me the positive, the imaginary, because it came from a square root, always have 2 answers. So I know there's also a minus I there, so that which will give me the 4 zeros to give me the degree 4. But this is what Ms. Chuka was talking about. This third part here, this solution point is going to help us in order to determine that a sub n. Okay, so let's go ahead and do it. We're going to start the same way as I did the previous problem. I wrote down the zeros that they gave me. X equals -4, x equals 1, x equals I, x equals -1. Again, I know that there was that minus because we have a double from the square root. I convert these zeros into its factors. X plus 4, x minus 1, x minus I, x plus I. I'm going to multiply all these factors together in order to get my polynomial. Okay. So when I do this, again, I'm going to start with the outer. And when I multiply all these out, again, I have this x plus 4. I'm going to do it again. I know that I squared is a -1. So it gives me this now 3 terms. I'm going to do the x minus 1 times the x squared plus 1. And then I'm going to combine like terms. And then I have this, right? So now I multiply the last one, x plus 4, which gives me this big polynomial. But let's go ahead and clean that up. Let's go ahead and combine our like terms and put it in standard form. And when I say standard form, just in descending order. I have x to the 4th plus 3x cubed minus 3x squared plus 3x minus 4. And this is where I ended up last problem. And again, since they didn't give me any more information, I just used a sub n as 1. But now they give me information to actually find the one with this information. And I'm going to use the solution point. The solution point says that if I plug in 0 for x here, the y value or the answer should be -8. So I'm going to use that in order for me to solve for my a sub n. Again, my y value is supposed to be -8, and everywhere I see x, I'm going to plug in 0. And when I do that, okay, I get -8 is equal to a sub n is equal to -4. Okay, so to solve for a sub n, I'm going to divide both sides by -4, which means that a sub n is 2. So now I can multiply that leading coefficient to my polynomial to get my final answer. Okay, so I have 2. The polynomial that I had was the x4 plus 3x cubed minus 3x squared plus 4x cubed plus 3x minus 4. And I'm going to distribute that to all of these terms. Okay, so when I do that, I get f of x is equal to 2x to the fourth plus 6x to the third minus 6x to the second plus 6x minus 8. Ooh, this was my last slide. Just I think I went too fast on these. Does anybody have any questions? Ms. Chuka, would you like to add something? No, okay. So I'll go ahead and pass it now to our presenters. Thank you for joining us today. Hope to see you again next week for our Friday Math Happy Hour.
I just wanted to say, if you want to download the presentation, I was on mute earlier, Ruben, I'm sorry. If you want to download the presentation, if they can put it back, there's an arrow on the top right. Let me just show you here. There should be a box with an arrow. You can click on that and it'll let you download the presentation. And of course, they will be posting this on YouTube, so you can always go back and view the video. Thank you all for joining us, and we'll pass it back over.
Alrighty, thank you so much to Mr. Carrizales, Miss Shuka, and Mr. Isasi for presenting today. Remember that next week in Math 13-14 we have the exam to review, and for Math 13-24 we have the system of equations, and from the student success topic we have the degree plans with Debbie Santana and Mary Favela. Thank you so much to the audience for coming today, and we hope to see you again soon. Thank you for this great review and have a great weekend. Bye bye.